Hello guys, I'm back. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. And today I am here with you to share a little bit about instruments. What is the relationship of the chemical process engineer with instruments or instrumentation? And I will cover this subject because I received the following question on my LinkedIn profile. Can you give me some link on how to design instrumentation for a process plant? So here, let's talk a little bit about instrumentation and process engineering. To start with, most often, the role of specifying an instrument is for the instrumentation engineer. The instrumentation engineer is the best person to do the specification of an instrument. Depending on how big or how small is your company, to cut costs, eventually you will be responsible for doing process and also doing instrumentation. And the role or the background of an instrumentation engineer most often is electrical engineering or electronic engineering or something related to that field of expertise. That is very different from the chemical process engineering plant design because we deal with thermodynamics, physical chemics, and etc. Some key points when we are talking about instrumentation. The first thing is that an instrument is a device used to measure a process variable. For instance, if we need to measure pressure, I can use a manometer to measure pressure. If I need to measure temperature, I can use a thermometer to measure temperature. If I need to measure level, I can use a mechanical device to measure level, and so on. Most often or usually the instrumentation can be analogic, so I will have only local indication where I have local indication, or it can be electrical or electronic. When we are talking about transmitters, level transmitter, temperature transmitter, pressure transmitter, I am talking electronic devices that will have some sort of energy to be able to transmit the information from the field where the instrument is installed to a PLC or to another controller where the automation will do programming to let this information available for control, for monitoring, for shutdown, and etc. So when we are talking about plant design, we are always talking about multidisciplinary team, and most often the instrumentation engineer will work with the chemical process engineer because we are responsible for developing the process, defining the process and what kind of instrumentation and control is needed for the process, and also with the automation engineer because it's the automation engineer responsible for doing the programming that was defined based on the control philosophy defined by the chemical process engineer. So there is an interrelationship between these three engineering. And what are some key points related to instrumentation? First thing is that the instrument specification depends on the location where it will be installed. If it will be installed in the field, in an open area, under the sun, under the wind, under the rain, the specification of the instrument must comply that. And we will need to define the IP protection. This is a nomenclature for European and international standard. If you go to American standard, you use NEMA. So there is a relationship between them, but what matters is that your instrument must be specified considering the ingression of dust that can enter in the instrument and with that damage the electronics of your instrument, and also based on water ingress, because if you enter water in an electronic or electrical equipment, you can mess with that, you can burn out that and lose your instrument. So one of the key points when we considering specifying an instrument is to understand the ingress protection needed for the service asked for the instrument. Another thing to consider when we are talking instrumentation is the hazard area classification where the instrument will be installed. If we are talking about a local transmitter or a local instrument where there is no source of energy to let this instrument operating, no problem related to hazard area classification. But if we are talking about transmitters, we need a source of energy to let the instrument able to transmit the signals for the PLC, for instance. And based on that, we need to inform in the specification datasheet of the instrument what is the hazard area classification. The nomenclature for the hazard area classification also changes depending if you are using the EIC or if you are using the American standard. But what is important is that first, the hazard area classification is a document to identify if there are flammables available in the region where the instrument or the equipment will be installed. And also, we need to consider what is the fluid that can be available in the surroundings. Is it hydrogen? Is it natural gas? Is it another flammable? Because depending on the fluid, it can be lighter than air, so any release will go to atmosphere, but if it is heavier than air, it can go down and accumulate in the surroundings, in the ground, and that will change the way that you deal with the specification of your instrument. Well, finally, to finish this video, the instrument is the definition of the instruments starts with the chemical process engineer. We, as the responsible for the process, we define what is the instruments needed for measuring the performance of the plant, measuring the operations of the plant, the shutdown, the alarms of the plant. But in order to be able to finish the specification, to the instrument engineer finish the specification, they need to know what is the normal range of operation of that variable. For instance, talking about temperature, to be able to finish the specification for a thermometer, the instrumentation engineer will receive from a chemical process engineer at least the process data sheet for thermometers or for temperature instruments. Based on that, we will inform the minimal normal temperature, maximum normal temperature. In some cases, we will inform also the pressure, the fluid, because with all of this information, the instrumentation engineer will choose the best material and the best specification for the instrument. The same applies for a pressure indicator or a pressure instrument where we need to inform the minimal normal operating pressure, the maximum normal operating pressure, and based on that, the instrumentation engineer will add in the specification the correct range of measurement of the instrument. The instrument, as you have seen, is a device to measure a process variable. But in some cases, in some companies, we add to the instrument list also the pressure relief devices, the control valves. Although they are not instruments by essence, they are most often responsibility of the instrumentation engineer to do the specification or to finish the specification. And we can add also analyzers, chromatographies. All of these usually is responsibility of the instrumentation engineer to do the specification, the technical approval, and the approval of the drawings of the vendor or of the supplier. In any case, all this stuff, the inputs, the first inputs are from the chemical process engineers because we are responsible for defining what are the contaminants, what must be evaluated in terms of contaminants. We define the flow rate for pressure relief devices. We define what is the pressure drop available and also what is the inlet condition and the outlet conditions of control valves. To do their jobs, the instrumentation engineer gets inputs from the chemical process engineer. And as we have this relationship, sometimes, as I told you, depending on the size of the company, the process engineer will face the challenge of dealing as using the hat of an instrumentation engineer also. So guys, if you like this video, share this video with another chemical process engineers or in groups in Facebook, Telegram, and etc. because this way you can help me to achieve 100,000 chemical process engineers around the world. This is it. I hope you like it, and I'll see you soon in the next video. Bye bye.